Today we're going to discuss on how to create image classification using TensorFlow and pre-trained model called MobileNet. In this project, we will classify the 6 different banknotes, namely 20, 50, 100, 200, 500, and 1,000 pesos. Welcome back to our channel, A3D Learning, where we share our personal projects to everyone. So, let's get started. The very first and most important part is data collection. First step is to download images from Google. Then, take video of the banknote at different angle and background. Extract frames from this video. There's also a separate video for this topic, so watch those videos. Third is crowdsourcing. I ask my friends to send me pictures of the money they have. Install first Git in your local machine. You can go directly to their official website and you can click download to download the file. Images were initially saved in the train folder. So we need to create 0, 1, 2, 3, 4, 5 folders to both test and validation folders. This corresponds to 20, 50, 100, 200, 500, and 1000. I prepared 453 images for each banknote. As a rule of thumb, we need to allot at least 10% for the testing and 20% for the validation. This is to make sure that the images we tested or validated are not used or seen in the training sets. Once the images are ready to shuffle, we will create a short program called autoshuffle.sh. Open the git bash CLI. Change the directory to where your training folder is located. Make sure that the sh file is located inside the training folder. The program will loop the 6 folders 0 to 5. Get the 90 images from the training folder and transfer it to validation folder. The same for testing, where it will transfer 45 images to testing folder. Once the directory is okay, we can run the autoshuffle.sh file by typing /autoshuffle.sh. After we run it, we can now check each folder if the images were transferred successfully. It seems like the program is working except for the folder number 4. One image is not transferred. It's because of the file naming. The file name has parentheses in it, so let's rename it and transfer it in the test folder. We will use the method called transfer learning, where we can reuse the pre-trained model like MobileNet. Just a brief explanation regarding the image. Each image is made up of tiny pixel, and each pixel is composed of combination of RGB colors for colored image. For example, for color white, 3 bytes of ones. These binary numbers will be flattened to an array. In neural network, basically it is made up of 3 layers: input, hidden, and output layer. The array that we just flattened will be fed to the input layer, and they are using a linear algebra for the computation. Since it is a supervised learning, we will prepare a label for each input, as shown in the right side. Based from the advice of machine learning experts, we need to have a validation sets. This validation is useful in tuning the hyperparameters. This will also show how biased or unbiased your model is. Actually, I tried almost 30 times just to get this kind of graph. The following are the courses I studied to be able to start and build an image classification project. To have a deeper understanding about machine learning, I would suggest to enroll this Coursera course from Andrew Ng. Even though you're not from mathematics background, it is easy to follow. Also, this course about TensorFlow. These courses were very helpful to me when I started to study machine learning. Also, if you want more on visualization of neural network, you can check 3 Blue 1 Brown channel. You need to have a Google Drive and Google Colab account in order to do the following steps. These are our final folders for our images, and we need to zip it into a single file. then upload it in our Google Drive. File uploading will take some time if you have a large file. Open the file in your Google Colab. First step is to mount the Google Drive. In this part, we will initialize the directory of where the zip file is saved. This will extract the folders from the PHP manifolder zip file. There will be a prompt to input the code generated by the Google. We also need to initialize the value of the class, which is 6. Reshape the images to the same size as shown. Epoch indicates the number of passes the entire training dataset the machine learning has completed. Augmentation is very useful when you have limited datasets. This will rotate, shift, zoom, and flips your images. You can play those parameters later on. Download the pre-trained model MobileNet and save it in a variable. To run the pre-trained model summary, it will display the different layers of the neural network. We'll do some tweaks in our pre-trained model, so this is our new model. Next step is to compile. LR means learning rate. Final step is to train the model. After training, I save the model so I can see it later. It will display the training versus validation accuracy graph as shown previously. Now we can start to predict the image inside the test folder. For me, I prefer the confusion matrix because it will show you how many images were correctly predicted and wrongly predicted. For example, for 20 pesos, there are 26 images predicted as 20 and 4 images predicted as 50 pesos. Once you're contented with the output, you may download the final model. These are the few models I saved during the training. Since the file extension is in H5, we will convert it to TF-Lite. But before that, we will create a Python virtual environment. Go to the website and there is a detailed instruction on how to do it. In your terminal, type the following. env is the folder name you want. You can name it whatever you like. As you can see in the right side of the video, env folder has been created. Activate the virtual environment. Save the H5 file outside the env folder. Both should be in the same root directory. Create a TF-Lite folder. The converted file will be saved here later. Code for converting Keras H5 model is also given in the TensorFlow official website. Copy that and replace the file name of the input and the output directory. We have an error, cannot find TF-Lite. What we can do is to go to PyPy official website and search for TF-Lite. We will install those TensorFlow packages to our virtual environment. TensorFlow package is a big file, so you need a few minutes to complete the installation. Now the TF-Lite convert is now added in the scripts folder. Let's try again to convert the Keras model. Okay guys, finally, this is our converted model, ready to use. How to use this model in our Android phone? Well, fortunately, TensorFlow has created many examples. We can download them from GitHub. Download it to your local folder by opening a separate command prompt. Try to explore the folder. Plenty of applications you can choose from. Open the image classification example. Copy the Android folder to your working folder. It is stated in the README file. The downloading of model is done during download Gradle. Open your Android Studio and open the Android project you just have copied. There is a Gradle version error. We can change the version as shown and click Try again. Let's try to check the asset folder, and here the MobileNet models were automatically downloaded. Connect your Android phone to your PC to install the app. There, at the right side is my phone loading the TensorFlow Lite app. We can try if this app really works. In the left side is the Android phone. I search images in the Google and point the camera to the image. Now we know that it is working, we can use our converted model. Replace the values inside the label.txt file. Go back to the Android Studio, change the TF-Lite file name to the file name of your model. We will use float MobileNet in project. I tried the quantized, but the prediction is pretty low. In the string.xml file, remove the other options and retain the float MobileNet. Let's run the Android again and test the new model. Watch the output. If you have background in Java programming, you can redesign the interface. Thank you for watching. Please subscribe and hit the like button if you like the video. If you have comments or suggestions, please feel free to comment down below.